Hi, I'm John Slater. I'm in the Dr. West lab here at Rice University, and I'm going to talk to you a little bit about today about nano-pattern surfaces that we use for cell engineering. So the idea for the patterning is we can understand how cells adhere and how you can manipulate that adhesion to control how they behave. And the applications would be that then you could actually take what you understand from that fundamental behavior of cell adhesion and how it controls the behavior and apply it to a three-dimensional tissue so you can start to create organs or tissues, artificial tissues that have blood vessels growing in certain regions. To make our surfaces, we start off with cover glass. And these are just little pieces of glass. They're, I think, a millimeter thick. See it here? So it's just a round cover slip. And what we do is we've machined these slides, or these samples, where we can insert the glass, and then we take it to our electron beam evaporator. And so what the electron beam evaporator does is allow us to deposit metal at a controlled rate and controlled thickness onto our samples. So what we do is we put down 2 nanometers of titanium as an adhesion layer, and then we put down anywhere between 10 and 100 nanometers of gold. And as you can see here, we put the gold into a little cuvette, and then so the electron beam is focused to here, evaporates the metal at a controlled rate, and then that will come up and be deposited onto our glass. So you see how that one spreads out, and this one she sees really well. You see how that one sticks up and that one doesn't. That's tough. You see the difference? We'll put our surfaces on here and we focus with the objective beneath, and then we have a box of 3 different lasers here. Those lasers are coupled into the objective through a scanning port, so it can actually scan the laser across the surface, and using the software on the screen here we can draw the shapes that we want. If you see that pattern, we can make the laser only focus just where the red lines are, and that'll heat up that self-assembled monolayer that we made. And the sulfurs that are next to each other that are bound to the gold will leave the gold and bind the sulfur next to itself, and that will actually float off the surface. Shown here is what I like to call I'll say the ECM is a carpet. So here in blue is fibronectin. Here shown in green are the cellular feet. And when I was talking about the bones, this is the actin cytoskeleton. So if you overlay all 3, you can see that the actin ties into the feet that attach to the carpet.